I'm Anil Kumar, and here is second question for you on concavity and points of inflection. This time I'll sketch graph of a rational function. So as you know, rational functions could have vertical asymptotes. So let me sketch some vertical asymptotes. Let's say these are my vertical asymptotes, and the graph of the function is kind of let me sketch it like let us say on this part it is kind of like this, right? So approaching 0. Here also it is kind of like this, approaching 0. And on this part we have kind of like this, right? So that is the graph of a rational function, right? Now for you the question is, you need to answer these questions. You need to find intervals when the graph is concave up. So you need to find intervals for, so you need to find interval for concavity. So we say concave up and for concave down, right? So that is what you need to find. You have to find interval when the first derivative is increasing or when it is decreasing. Okay, so decreasing. You need to find interval where the second derivative is positive and where it is negative. And lastly, I would like you to find point of inflections, right? So point of inflection. You can pause the video, answer the question, and then look into my suggestions. Now to answer such a question, let me further label this. Let's say this is x-axis, this is f of x. And let's say the vertical asymptotes are at a and b, this is the origin. That should help us to answer most of the questions. We also, that should help us since the concavity changes at 0 in this particular case. So that should be good enough, right? Now with these points, it's kind of very easy to answer this question. As you can see here, as far as the concavity is concerned, so if you draw a tangent line, the graph is below the tangent line in couple of portions. So definitely between minus infinity to a. So between minus infinity to a, concave down, it should written here, minus infinity to a, it is concave down. Also, you'll find this portion between a to 0. Let's write between a to 0, it is concave down. Since tangent line, if you sketch, graph is below the tangent line. You get the idea, right? Here it goes across, so that's a different point. And in this portion also, graph is below the tangent line. So union b to infinity, right? So this is the portion where it is concave down, correct? Now to find the portion where it is concave up, if I draw the tangent line, graph is over the tangent line from 0 to b, right? So it is from 0, let me cross this, from 0 to b, it is concave up. Perfect. Okay. Now concavity is directly related with the second interval, second derivative. So the interval for the second derivative being positive is when the graph is concave up. So I could write straight away the answer is 0b here, and for negative, which is these three intervals, it will be minus infinity a, union a 0 and union b infinity, correct? So you could directly connect them. Perfect. Now as far as the intervals of increasing and decreasing are concerned, the first derivative is always increasing. You can see this portion, right? So it is, let's begin from here and understand what is happening in this particular case. For concave up 0 to b, if you draw the tangent that represents the first derivative, it is 0 and then positive and more positive. So whenever it is concave up, the first interval is increasing, right? So concave up, increasing means 0 to b, and as far as decreasing is concerned is when it is concave down. Perfect. So these three will come in where the interval is decreasing for the first derivative. So minus infinity to a and union a to 0, union b to infinity. You get the idea. So that is how all the things are related, correct? So when we say we have concave down, for example, right? So let's say concave down corresponds to interval decreasing, and that corresponds to second derivative being negative. Do you see how all these three things are related? Similarly, you could say concave up means first derivative is always increasing in that interval, and the second derivative will be positive, correct? Now what is point of inflection? The point of inflection is the point where the concavity changes, correct? So the concavity here changes at 0. That is the point where it changes from concave down to up. Do you see that? Concave down to up. So there is one point of inflection, and that is at x equals to 0. So point of inflection is indeed where concavity changes, right? I hope with this video all the things have come together, how we relate concavity with derivatives and how do we find point of inflection from the given graph. Now we'll take a few examples, different kinds of equations to do the same thing. Thank you and all the best.